Hello! This episode of Finnish machining is dedicated to soldering. I will go through the materials that are available that I have here in my workshop. It's quite a decent collection. And then we are going through the tools needed for soldering. I don't have a lot of them. And then we are going to solder different materials together. This will be exciting. And after all this is done, in the last leg of this episode I will go and solder the electronics in this welding position. So let's go and look what kind of solders are available. So let's start with probably the most unusable solder in a workshop. Well, if you are doing car body repair work, then this type of solder would be your choice. Comes in sticks like this, and it's intended to put on top of your car body if you have a dent. So then you fill that dent with this one. And this tells the juotostina, so solder. And this one contains 37% tin, and rest is lead. So it contains quite a lot of lead. So that's one reason why this is not very suitable for electronics work. You should have a lot more solder, tin in your. So, we don't do anything with this today. This guy here, this is 2 millimeter wide, and this is very good for soldering electronics and all sorts of wires. First of all, it consists of this particular solder has lead in it. So this is probably illegal today. So, but anyway, this one has, in addition of being solder, it has flux inside there. There is a core which contains flux. So using this is very convenient. It's really easy, and this is probably the all-purpose solder you would normally use in your workshop. Electronics is a little bit different. This one is not very good suited for electronics. That's one. And then we have a broad range of solders intended for electronics. And if we go from here, this particular solder here, that's very thin. It's actually 0.23 millimeters, and this is really good for soldering very small parts. But then of course you have to have the proper soldering iron, probably a magnifying loop which you are using to use this one. This particular one contains it contains lead, and it's very good for durable soldering joints in electronics. That's that. Then we have this guy, and this is now a different. It's as thin, almost as thin. This is 0.3 millimeters, but this one, and this one also has the flux in the core. And also this one has the flux there, but this one doesn't have any lead in it. Instead, it has silver and copper. And with this tin, the difference between these two is that this one requires a lot higher soldering temperature. Something like this is good from 270 degrees Celsius. And it still solders very well at 350, not higher than that because it burns off the flux right away. This one you need already like 300 at the beginning to start with, and after that it goes up to 300, almost 400. The best results are somewhere a little bit over 340, at that range anyway. So this also had the core. And then we have this Japanese solder, which has proven to be really good. I don't know why, and I actually don't know what are the materials in this one. It contains lead, but the flux is something very special in this one. It works in higher temperatures. When you need to solder with higher temperature, then this one is good because that flux doesn't burn away. Yeah, those were for electronics. And then we have this guy, and this one is quite special. This is solder, but this is intended for soldering materials that are really hard to wet. It's called, the brand name is Alusol, and this one has very aggressive flux inside there. And well, after soldering you should first of all have good ventilation in your room, because this generates really bad type of fumes, and it contains lead and whatever it contains, it's somewhere there, but yeah, but this one can be used, for example, to solder aluminium. It works, and the brand name is Alusol. Okay. Then we have this guy, and this is exactly like the body solder I did show you, but this one is really good for soldering if you don't want to add flux into your things. So this one is good. If you want to use some other type of flux and you don't want to, and this also, it's 3 millimeters in diameter, so there is plenty of solder available. And this, it doesn't tell, but this is CU routed. It means that this can be used with copper tubes, for example. If you want to solder your copper tubes, then this one is suitable, and it makes a very good contact with copper, doesn't become brittle in the long run, and etc. Well, the lead in the metal makes it so that it doesn't become brittle. That's that. Then we have this one, which has a poison symbol, and yes, this contains 62% tin. Then it contains 36% lead, and finally 2% silver. This is used to solder those surface mount components in printed circuit boards. Well, as you can see, this is almost empty, not much left there. This is this particular material. This has the best before date. They go bad in 2 years if you are not using them. They harden inside there, and you cannot use them anymore. That's one. And then as the last thing we have this is called Rosol 3. This is intended to be used in copper fittings. It's a paste, you can see there. So it's similar to this one, but this one is intended to be used same way as this one, this copper tube soldering solder, but this one contains the flux. So they have pulverized the tin and whatever there is, and then they have mixed everything with the flux. And then you just put this on top of your copper tube like this, for example, there, and then you heat it up and it will make you a perfect solder joint. So this is for copper tubes mainly. Okay, well, I don't have any more solders. If you plan to use soldering, so this one is your choice. This is if you are not doing very fine electronics, I mean. So then you can cope with this one. This is all you need. So you probably noticed that these quite many of these contained the flux embedded into as a core inside the solder. Well, I don't have at the moment the flux that is used with electronics. I don't need it. I have never had a great need for that one because of my solders contain that. But sometimes I use this one. This is soldering paste. And this one is very corrosive for the first, and it you spread this thing on your on your workpiece before you solder it. Well, the flux, what is it doing for the solder? Well, actually, it has two functions. The first function is to keep the surfaces clean and even clean up them somewhat. Therefore, this is somewhat corrosive. It contains materials that corrode or try to make it a bare metal. Then the other function is it acts with molten solder. It acts much like soap in water. It makes the surface tension of solder a lot less, or removes it almost completely. So it makes it so that it wets easier your work. Then about the equipment. Let's start with the... I have a soldering iron like this. Well, normally, and I don't have, this is almost everything I have as a soldering iron. When you have a proper soldering iron, you can manage, if it is a good one, you can manage everything with single tool. Well, this one contains, it's an interchangeable, you can pull it out like this, and then you can choose, here are some bits, some of them are really long, like this one, it has a very pointy thing, and then we have some very special tools. This one is intended to take some circuits off the board. And then I have this, which is a general or all-purpose tip. This one is very powerful. 50 watts doesn't seem to be a lot, but when the 50 watts is here on the tip only, then it's really good. You can solder really thick copper with this one. So yeah, okay, that's one soldering, normal soldering iron. But well, if you are planning to get yourself a soldering iron, I would buy one that has a thermostat in it. Those really cheap soldering irons that do not have a thermostat, they are crap. You will actually end up destroying your work with those. The temperatures go way too high if they are powerful, or then the temperature is way too low for your soldering. This one, for example, you cannot adjust it anywhere, but the tips are rated for a certain temperature. So it's actually the tip itself that adjusts the temperature. There is a thermostat, really. And then that's one. But if you are working outside under your car and so on, so maybe sometimes it's very hard to get your electronics, your some power there. So then this guy is a very good one. This is actually butane soldering iron. There are in the market other types. This one is Weller. This is very good. But I know there are really bad ones. I have tried really bad ones which won't work at all. This one works. It has an equivalent power of something like 100 watts. But unfortunately, this one doesn't have a thermostat. It heats up really fast, and you have to be careful with this one not to burn your wires, etc. This is one. And then we have, if we go on with the soldering tools, we have this. This one is actually a heat gun. It blows hot air from this very small nozzle, and it's very powerful. This is 700 watts. Yeah. Because the air is temperature controlled. There is a quite big amount of air coming out, and it heats up the air to a certain temperature. You can there is a thermostat in there which you can control the temperature from 100 degrees to it was something like 400. And then you can also control the airflow, how much air is there going. And this is very good for soldering very small surface mount components which are present on things like this. There you can see some smaller, you might see, for example, that one, the score one. It's a typical target for soldering with this one. So yeah. And then for repair work we have a guy like this. This one is also Weller. And what's special with this one is that it first of all it heats up your work. But then there is a button here in the side. When you push it, it will suck. There is a suction, so you can suck the solder away. And well, I should clean this up. It's filled with solder at the moment. It should be kept really clean. Yeah. Anyway, this is a very good tool when you want to undo your bad soldering. For example, let's assume that I need to get away from that connector there. So I go here under, and then I put it here like this, and when it's molten I push the button and it sucks the solder away, and then you repeat this for every pin, and after that you can pick up your component with no worries at all. It comes like nothing. Furthermore, some of the materials and tools, of course, when you are soldering, let's see if I can find the bad example I had here. Okay. Well, what's wrong with this one? This is copper. I cannot solder this like this. The reason is that it has a heavy oxidation, and this one doesn't work with soldering. So you need to clean it up somehow. And now you could clean this up chemically. I don't like those. I use mechanical cleanup, and for this I have two choices. This is normal steel wool, the very fine variant, and then I have this, which is 1200 grade emery or wet sandpaper. This one is bad in a way that it leaves some residue in on the surface, but sometimes you really need to use this. You cannot get rid of your dirt otherwise. But usually you can clean these up with steel wool like this. You just wipe it a little bit. I can show you very soon what I mean. Like that. There is your I cleaned up. Now you can see the spot. That one you can solder. On the next spot here you cannot. It just does not wet. Whatever you do, it doesn't wet. Okay. And now there are some places which you cannot get the oxidation away, and I have here a good example of. Is this a good example? No. Well, that's a good example. I have here some just an ordinary wire, which is very hard to solder. And if you look carefully into it, you can see it's not looking very good. It has oxidized here all the way inside. It should look more like this. This is a good one. This solders right away. So this one is really bad, and this one we don't use today. Throw it away. And for every soldering operation you should clean up your surfaces. This is essential to get the soldering going on. Well, that's about the materials, the tools, etc. So the next thing I will show you, we will experiment with some of materials. Now this next demonstration is a little bit hard for me. Okay, let's assume that you have to attach these two wires together. And I will now try to demonstrate you the wrong way to do this. And well, first of all, you take those two and then you think, okay, let's put them like this together. Okay, there you are. And then let's solder those. Then you take your soldering iron and then you put some solder in there, like that, and then you put it like that there. And nothing happens. Yes, it attaches somewhat onto the surface. So why is this? Why didn't it do? Why didn't it work? It should. The soldering iron is hot enough. You had some flux in your solder, but it still doesn't work. So the reason is soldering is a process where you have to bring the temperature of the object. In this case, the object is these two wires. You have to bring the temperature of those above the soldering, the melt point of this solder. And furthermore, you have to have flux in the object, not in the tip of your soldering iron. You have to have the flux inside here. So, okay, let's solder this the correct way. This is still not the proper way to do this, but let's solder it. This is a lot easier for me. It makes me feel bad. So, first of all, we need to warm up this wire up to a good temperature. So, what I do, I put a little bit of solder there to transfer the heat. And then I melt the solder into this workpiece, like this. You can see how it goes into there, and then you get the flux into there, and there you go. I don't put the solder into the tip of the iron, I put it onto the workpiece itself. So now, well, that's a proper joint. Well, these two wires are now well soldered together, I'm pretty sure this is a proper joint, but this is not the way you should do this. This looks really bad in my books. It's still quite hot. And there are quite a lot of complications in this one. Now assume that you would like to isolate this somehow. Well, maybe you could bend it somewhere like there and do it like this, and then wrap some plastic tape over that. Not a very good idea. This is not the proper way of attaching two wires together. Yes, it will do the job, but it's not beautiful for the first, and then it takes triple so much space around here. So if you have to thread this somewhere into a hole, it might be a problem. Okay, not like that. First of all, now we have, well, I was prepared. So you have these which you have to bind together. You need to think ahead a little bit. Well, how to isolate this? Well, this material comes in help. This is a plastic tube that will shrink when it's warmed up. So, and thinking ahead, think that this wire would be going to some compartment through a hole there in the distance, and this one is attached already in some motor, for example. So then you solder these two things together, and then you think, how about the shrink wrap? Okay. So therefore you put it in advance there. I don't put it in this case because I have loose ends here, so I can do it afterwards. So let's put that aside a little bit. So what to do with these two wires? You put them like this. You try to thread them together like this. Like that. You see? They are now like that. Then you just try to put them a little bit more together, like this. And there you are. You have a very nice thing there, but it's still, of course, not a good joint. And then you solder this one. And again, don't put your solder. Yes, I will put some here so that it transfers the heat. But after I get the heat going, I will use the workpiece to warm up my solder. It still doesn't want to cooperate. Now it's cooperating. And then I just solder this together. You see how the solder melts here around. There you are. That's a very good joint. Now when it solidifies, this is still might be wet, melt, so you have to wait a decent time so that it really cools down. Now if you look around it, it's really, and the solder has gone also into the, it's actually so far, it's probably penetrated up to here, from there up to here. There is a capillary action going, and also to this side. So, and this joint is really durable, and it's also already cooled down a little bit. Now I put my shrink plastic here somehow, if I can get it there, like on top of that. And then I take my heat gun. You might have different heat gun than this. I have this, and then you heat this shrink plastic like that. You heat it up and it will shrink around this joint. And you heat it up enough so you can actually see how it begins to touch the plastic. So this is now weatherproofed, so to say. These are airtight actually now. But this one is now a proper joint. It goes very easily inside holes. It's a little bit stiff, of course, at this portion, but it's still, well, this one I would accept as a good joint between two copper wires. Yeah, okay, that was one. And then we have, sometimes we need to put connectors like this into there. Of course you can use the crimp tool to squeeze this down, but in order to make this joint durable that way, it's a valid way of doing this, but you need the proper tool for that one. The ones that they sell, those Abico, they are not very good for making such joints. You need a lot of force to get these proper. So what I do, I usually peel off this plastic thing, throw it away like that, and then I solder. Let's take another wire. So then I solder this here. Let's assume I had to make this joint. So I thread it in there. And now you could probably squeeze this down a little bit, but that's absolutely not necessary. What I usually do is that I take these like that, so that they come through the hole and then come back a little bit there, and see that it's about there. And then what I do, I will solder that one. And after this you have a very good joint here. And again, see, I'm not melting this solder into my into my soldering tip. I'm melting it into the workpiece. That way you get the flux where it is needed, and you get a very good joint. This one is really good. Doesn't come off, and well, you can also pull it, and this will work. Okay, that's one. Well, so far the materials have been really easy. And then my favorite material for soldering is this. This is not copper. This is brass. And for this one you need to clean up before you even think about starting to solder it. You have to clean it up like that. You see, there is now a shiny surface. And if I want to solder a wire in there, it's really just like this. Oh yeah, this wire has pre-tinned. It's a copper wire, but each of those small wires have a very thin layer of tin on them. So this one solders really easily, but you still need to have it. So now if I want to solder it there. Now this is a little bit more, let's frame you, okay, like where is the correct place? Okay, maybe that one, maybe. So, how to do this properly, I don't know. I usually just put my soldering iron on top of there, and then I start to go around with the soldering iron here, and put some tin around, and there you are. You can see how, I will point this out to you. You can see how this solder is like spreading around here. And this is because the flux took away the surface tension, so it can do that. Without flux, it won't, first of all, wet none of these materials, and then it would be a big ball there. So, and that's also a proper joint now. It sticks there and won't come off. Yeah, okay. And then let's go into harder materials to solder. Let's take now my vise here. Because I want to have this. Well, brass is really easy. This one is brass. No, it's brass. And this material is iron plate, a normal iron plate, but it has tinned surface. I have some of this material in my workshop. It's really nice when you want to make, for example, magnetic shieldings. This is really good for that one. I try to put it somewhere here in my vise so that it doesn't fly away. Okay, there you are. And now this one solders really nicely because it already has the solder on top of it. But let's try to solder something that is not so well. For example, if you want to solder this is bronze. If you want to solder some bronze into that one, let's assume we want to do that. This is going to work really nicely. There is nothing I would change the direction. There is nothing very hard about this. Well, the only thing is how to warm these up. So you need to warm this bronze thing up. And when it's warm, it takes some time, although my soldering iron is really powerful. And then you just put the solder inside there, and voila, there you are. It went like that. Please cool down. Oh, it's very warm. So there you are. It's a really good joint, and okay. So let's. I will use this. Okay. So this kind of plate solders very easily to copper, all sorts of metals. It's very usable in a workshop if you want to do some soldering. That one is good. Then let's go to a little bit harder materials to solder. This is actually cold rolled steel, the mild steel, and if you want to solder this, you have to clean it up properly. I roll it there, and maybe in this case you might be wanting to do it with emery or some abrasives to get it really clean like this. Now we probably can solder this one. So let's this is somewhat cumbersome. Now iron is a very bad heat conductor. It's also it doesn't conduct electricity very well. So they go hand in hand, the electric conductivity and heat conductivity, for some reason, I don't know. So let's put this, this is again copper, which has, in this case it doesn't have, tin. This one has silver on top of it. And let's put it like this there now. And let's try to solder that one. So I let it fall down there, and that was intentional. So let's see how this works, if I can get it wetting. Usually you have to use a little bit higher temperatures Oh yeah, it got wetted. So now, okay, let's see now. I put my soldering iron there, and again I warm the workpiece. And now, because this iron is so bad heat conductor, it doesn't want to wet very. You have to wait quite a long time for it to solder, and then release that. After that, when it now cools down, we should have it's still molten. Okay, now it's frozen. So now we have a very good, or do we have a very good? Yes, we have. We have a very good joint there now. Well, do we? Is this a good one or not? If you look around here, you cannot see any solder here. So it's not a good one. We really need to put more solder into it. So not success. Let's put a little bit more solder into it. And see that it really... Now let's wait a little bit. There you go. So mild steel can be soldered quite easily. This is mild steel, and this is now copper. And so copper and mild steel go along quite well. No trouble at all. There you are. And you can also solder brass, bronze with mild steel. You can also solder like this. This is brass with mild steel. It goes very well. And now you can see this is properly there, and well, I could trust that joint. Well, let's go into harder materials. This is alloy, this is silver steel. And now, let's see, it looks like it's clean, but is it really? So, in this case, even though it's like that, I would like to do this. Just rolling it there. So now we have a decent clean surface there. Let's see if we can wet this one with the normal solder. Well, I'm pretty sure. Let's see. This is an alloy. It means that it has some... let's see. Oh, if it wets, it's somewhat wetting actually. Yeah. So this means that silver steel by itself can also, or can it? If you look around there, is it a good joint? Would it make a good joint? I think not. Silver steel is typically very hard to solder. Oh, it's hot. Oh, cool down now. Well, it's funny. Iron is such that you can hold it on this end quite easily, and this one is already melting solder. So I put it into my vise here. I would like to show you what... How can I put it here? Okay, there you are. Now, let's take alusol. It was this very aggressive material. This one, I would like to put this into my soldering iron, and now when I put this one here, this usually does the trick. And this is, believe me or not, it's really, really tough. The smell is like directly from whatever. Hui. So now it made a very good contact at places, but well, and it's hot from there. But okay, silver steel somewhat solders, but you have to be a lot more careful with this one. And well, cleaning will help you a lot with this one. It's hot as, oh man, it's hot. Then we go towards more impossible materials. This is a broken center drill, and let's see if we can wet this one. So that one is somewhat wetted, and let's see if we can do. Well, this is like. I'm trying to get. Okay, now we have there. I believe there is a proper surface. Let's put it just there. I'm really suspicious about this. I don't know why you should solder like high-speed steel in your workshop, but maybe there are some cases where you want to do that. So let's see if this solders. So we need to have some heat onto that one. We have to wait that it heats up. So this was high-speed steel. Does it go there? Does it wet? Let's see now. Let's wait. We have to heat it up really properly. Actually, can you see? It wets. You can solder also high-speed steel if you want. That's properly wetted, so no aggressive flux is needed in this case, and this is hot, so therefore I'm digging it up with this. So you can solder high-speed steel as well. So, but it's again, you need to be a little bit careful with this one, as well as with this silver steel. And then we go up to the difficulty. This is carbide. I'm pretty sure this one won't wet. I don't know how to get this clean. Let's see if I can. This is when you need abrasives to clean, for example, your. Hopefully, it's now clean at some point at least. Well, again, you might need to solder carbide in case, for example, you are making probes to measure something, and you want them to tolerate heat or something, or be very sharp and stay sharp. So then you might need to solder your carbide. So this is now carbide. I'm pretty sure this is tungsten, so let's see now. As you can see, it melts the solder, but it just skips away from that. Okay, this didn't work. Let's take our aggressive. I put some solder there to keep the temperature up. This is now the aggressive one. Let's see if this works. It melts. Well, I would say you cannot solder Carbide is something you cannot solder. Impossible. That's peregrine. That's the peregrine, whatever. It's you cannot solder it. It's hopefully the need never arises. I need to do that. Then we go something that is generally thought as unsolderable material. This is aluminium. And you can solder aluminium. Yes, you can. But the first thing, of course, is that it needs to be totally clean. And this one you can clean up, and you shouldn't actually put any abrasives on this one. It needs to be absolutely clean. Now, I think this is now clean enough. Let's open this up a little bit. And now the trick to the aluminium is difficult for a reason. First of all, when aluminium is like that, there comes oxide layer on top of that. There is already, but it's quite thin at the moment. It grows up during the time, and you should thin it up as much as possible. You cannot get totally rid of it because it generates a new oxide layer in milliseconds. So you need to get rid of it as much as possible. So let's solder, for example, this one into there. And now, what is difficult with aluminium is that it's a very good heat conductor. It conducts the heat right away from your workpiece, and therefore you need to have either warm it in advance, or then just hopefully I can get this warm enough. Aluminium can be soldered by using proper tools and proper materials. Well, this doesn't look good, and as you can see, the temperature was not good enough, but let's see if I can rip it off from there. If I squeeze this a little bit, as you can see, it's there. It is there. Now the next material is something that you might encounter into. It's this wire. This is Constantan, resistor wire. And this is almost impossible to solder. It doesn't want to solder with copper. For some reason, if you wrap this around a copper wire and try to solder it, it doesn't wet. But this one, the mild steel. Let's clean up this a little bit. I will show you this Constantan, this resistor wire. It contains iron. It's mainly iron, but then they have there is aluminium and chromium in this one, and this makes this unbelievably hard to solder. But you can do that with just by I'm wrapping it around here like that, so that we can see whether it solders like that. And I forgot to do something. You know what I did not do? This one, I have to do this again, needs to be absolutely clean. If you try to solder this one just like that, it won't work. So you need to clean it up almost clinical, so that it's bright and clean. And then we had this, which was also cleaned. And this one also, like aluminium, it generates an oxide layer quite rapidly on top of it. And then I put it here, like that. And then I put this into my vise. Okay. So now we have our resistor wire there. I try to put it so that you can see it. This stuff creates a horrific thing. So then you can start. I usually start by putting some ordinary solder here, so that it sort of transfers the heat. And then I put this aggressive solder, and you might see soon that it really works. That should do it. There you are. Resistor wire soldered to a mild steel stick. So this was the demonstrations of soldering, and then finally soldering the control panel connections, what need to be soldered in that one. Rest are done by screwable connections. So, well, this also concludes this episode of Finnish machining. Well, in the next episode I think we will continue with that thing. There might be one extra power supply, some connections between the box itself and the control panel, and then final testing. But this all will be in the next episode of Finnish machining. Till then, bye!